Hello and welcome to the fifth video in the STALKER mod making tutorial series. In this one we're going to continue going over some basic blueprint concepts. We'll go into the different events that I did not explain in the previous video, how to efficiently debug your blueprints, and then features such as comments and variables and a whole bunch of other things. So let's jump into it. We are going to be continuing with the mod that we made in the prior video. And what we're going to do is just add in more blueprint scripting to get money under different scenarios. So with the add money mod, which we made in the previous video open, let's go ahead and reopen our mod actor. Let's start with one of the events that I told you to delete that was auto-generated for you before, the on-tick event. So to get that one back, go ahead and right-click and then just type in T-I-C-K. It should be under Add Event, Event Tick. Just to refresh your memory about Event Begin Play, this is an event that fires whenever our mod actor object, the object that we're designing this blueprint within, whenever this mod actor object is added to the game world, this event will fire, which means that all of its subsequently connected nodes will all be triggered in order, and it will happen just once. Event tick, on the other hand, is an event that is fired continuously throughout the lifespan of this object. So by default, it will fire off once every frame. As we can see, if we hover over it, we get a nice little tooltip that tells us event called every frame if ticking is enabled. And actor objects by default are going to have event ticks enabled. If we wanted to add, or at least duplicate what we've been doing for this event play, let's say we wanted on a recurring basis to continuously play that cash register sound and execute the add money command, we can actually just copy these two nodes by highlighting them and then pressing Control-D to duplicate. And then it will create a duplicate of these nodes that we've selected. So I'm actually going to connect those up. We have an event that's fired for event begin play. This will run once. And we also have another string of nodes that will be ran based on the event tick being fired. So essentially this will call our two nodes on every frame. If you have a game you're playing at 60 frames per second, that means this is going to be fired 60 times every second, or once every 60th of a second, which is probably not a good idea in this case when we're playing a sound. I mean, we can go ahead and save it and run it and see what it looks like, because we can test it in the editor. It's probably not going to sound very good, so headphone warnings. Yeah. So let's go ahead and try to figure out a way to get these two nodes to continuously fire, but at a frequency that's far less than 60 times a second. There's a couple different ways to do it, but probably one of the easiest ways to do it is to just modify how frequently a tick occurs for this actor object that we're in. And we can do that up here in the upper left. If we click on mod actor, over to the right in the details panel, we see we have some options where we can modify how this actor behaves when it's in the world. First, we have a property that says start with tick enabled. If we disabled this, saved, and then ran the game, or ran the test rather, we can see that the only thing that's going to happen is our event on begin play will execute after 5-second delay. But the tick won't happen at all because we disabled it. So going back, clicking on mod actor, I'm going to re-enable that. We can see the next property down here says tick interval in seconds. It is currently set to 0, and our nice little tooltip here tells us that this is the frequency in which the tick function will be executed. And if it's less than or equal to 0, then it will tick off every frame. So we can change that behavior by instead telling this to fire, let's say once every 2 seconds. I'm going to put a 2 in here. And now let's see what happens. So compile, save, and play. So we get one immediately. and then once every 2 seconds, plus our 5-second delay. It may be a little bit hard to understand which ones are associated with begin play and which ones are associated with event tick. Fortunately, there is a pretty nifty feature in Blueprints that when you're testing it in the play and editor, the PIE mode, you can actually view with visual indicators of what node is actually firing at the same time you're playing. So I'm going to go ahead and split off this mod actor window. So I'm going to put these side by side and zoom out a little bit over here on the left. I'm going to get rid of details so this is a little bit easier to see. Normally I would have this running on a separate window, or a separate monitor rather, but look up here in the top right of our event graph. We have a drop down here and it tells us no debug object is selected. Well, I'm going to tell it to use the mod actor object for debugging. And now, if we press play again, we get these visual indicators for which event is actually firing. This will come in handy later on when we're actually doing some more complicated control flow logic type things. But for now, let's move on and add in the actor overlap. So I'm going to go ahead and pop this back. So the next event that I'm going to go over that I told you to delete from the last video was the on actor overlap. Go ahead and just type in actor overlap. There we go. Event actor begin overlap. And let's say we also wanted to, every time something overlaps with the geometry of our mod actor, we want to do this again. At the moment, this isn't going to do anything because our mod actor has no way to determine what its geometry is, what its volume in space is. Nothing will ever overlap it if it doesn't actually represent anything in 3D space. So again, that's something we can modify. If we open up our viewport, if you closed it, you can get back to it by double-clicking on mod actor. And in here, we're just going to go ahead and add a component, a collision component to this, so we have some physical representation in the world of our mod actor. I'm going to click on add, and then I'm just going to type in box for box collision. There we go. When it is added in, it has a default size and shape. Now, we're just going to leave it the way it is. We don't really need to modify it. So I'm going to go ahead and compile and save. And now when we look at our third person map, wherever we put our mod actor, there we go, it's over there. We can see now it has this little box around it because now it does have some sort of 3D representation. Now that's pretty hard to see. So what I'm going to do is I'm going to go back to mod actor and I am going to change the line thickness and color. I'm going to just change it to thickness of 5. Yeah, that's going to be obvious. And maybe change the color to something more like along the lines of green. That's fine. I'm going to go ahead and save it. So now that we have some sort of collision representation for this object, we can go back to event graph, and this will now trigger whenever we step over it. And just to illustrate that, because it may be a little bit harder to hear, if we had this event tick firing off every 2 seconds, I'm going to go ahead and disconnect temporarily. I'm going to break the link between event tick and event begin play. So now the only thing that'll fire off our play sound and execute console command will be this event here for actor begin overlap. So save, play, and we can see we can't see it. So there is a reason for that. If we go back to our object in the viewport and we click on box, there is an option down here towards the bottom. We can see it's visible. This means we can see it in the editor. If we disable that, then we can no longer see it in the editor. But there's also this option called hidden in game. And this right here, by default, because this is supposed to be an invisible object, this is just a collision box. By default, it's supposed to be hidden in the game. But we're going to deselect that for our purposes because we want to be able to see where that collision box is. And now I'm going to save. And then play. So there's that box. So we can see when we hover over it, or when we pass through it rather, that event is being fired. Another useful feature is a node called PrintString. And this is a node that only works in the editor. It won't work in game. I want to be able to tell the difference between, without having to look at this while I'm using the play in editor. I just want something to pop up on the screen to tell me which event is actually driving, the sound and console command at that moment. So if we put this print string on here, every time that this node is encountered, it'll print whatever we put in here in this in-string box. So this first one is begin play. So I just wanted to put begin play on screen whenever this node is triggering. And I can do the same thing, highlighting this print string, pressing Control-D to duplicate it, and then connect it up down here to our event tick collection of nodes. But I'm going to change this to PICK for tick, and then one final duplicate for begin overlap. And if I save and compile this and then run it, in the upper left, it may be hard to see, but we have some labels popping up on screen. And right now they're only lasting for, I believe the default is 2 seconds. We can modify that by expanding this print string node and telling it to stay on screen longer. But there's a little bit easier way when you use this print screen to view what's going on. If we look at the output log and then we play this again, there we go. We can see right here, tick, tick, begin play, tick, tick, etc. I can actually filter this output log to only include those messages. So those messages come up under log blueprint user messages. So if I deselect everything except for messages and go to categories, deselect show all, and just find log blueprint user messages. Yeah, there we go. So right here. Now I can see, even though on screen it only shows up for 2 seconds at a time, I can see the entire history of what event was firing and when. So let's do this again and move over our box. And we can see it's not actually, there we go. It wasn't keeping up because I wasn't scrolled to the very bottom. You can overlap, take overlap, etc. You get the idea. So now let's continue on and make some more changes. Going back to Mod Actor, there's one thing that I would recommend whenever you see a bunch of repetition, like play sound, 2D, execute, like whenever we're doing this over and over again, it's probably a good sign that we need to use something called a macro or a function. And what these two things are is they basically allow us to take a bit of our node structure and put it into its own little block. It allows us to reduce the overall size of the graphs by creating an object that we can use over and over again. I am going to go ahead and show you how to do that by example. So just like we did before where we duplicated these two nodes, we're going to highlight them both, and instead of duplicating them with Control-D, I'm just going to right-click on any of them, and then click on this Collapse to Macro option. And what this will do is it'll create a new little block and put it into the graph where those two elements we just highlighted were, and then down here on the bottom left, we'll get a prompt to change the name of whatever this new macro we created is. So I'm going to rename this as play sound and give money, because that describes what's going on inside of this macro. And now if we double click into it, we can see that this macro contains 4 things. First, it's the start of the macro on the left, and then the 2 nodes that we copied and put in here, followed by an output to say that, once this macro is done, then continue on doing something else. So now we could actually replace everywhere we call the play sound 2D and execute console command, we can replace it with this macro that we created, and it'll do the exact same thing. However, one thing that I want to change to make this a little bit cleaner is I actually want to incorporate this PrintString functionality into our macro and modify the structure of our macro to where we can provide, when the macro is called, the actual string we want to print on the screen. So let's do that. So we're going to go back into the play sound and give money. Let's add in that print string. There we go. Connect it up in line. We can see that there is an input pin for a string on PrintString. So we actually want that setting to come from outside of the macro. So the way we do that is we need to create an input parameter whenever this macro is called. We can drag this pin inside of inputs to where it says add pin to node. And if we drop it, then now we'll have a new parameter. Now if we want to change the name of it, over here on the right, under the macro details, we can change the name of that to event name, because that's really what we're printing in our debug here. You can call this pretty much anything you want. So now we have an input string that we can pass to PrintString, and then every time this is ran, it'll print the string of whatever different string that we call each time we run this macro. So to illustrate that point, let's go back to our event graph, and we see now our macro looks a little bit different. Now we have an input called event name. We could go in here and type in begin play. So for example, there we go. And now we can get rid of this print string because that's actually going to be happening inside of this macro instead. So we could delete all of these, duplicate the macro instead, and then change the name. Connect these all up. And now our blueprint graph is a lot smaller than what it was before because we've created this reusable piece of code that we can tell it to do whatever we want inside of it and call it as many times as we want and in any place that we want, as long as it's within this mod actor blueprint. So let's go ahead and test this and make sure everything works the same as it did before. Yep. And one other thing we can do is, instead of having a separate play sound macro for each of these 3 events, there is a way we can organize this to where we just have one node for play sound and give money, and then have all 3 of these events just converge in together. And the only problem with that is it works exactly the same as what we had previously, except for every single time we call this, it's going to say tick instead of where it's coming from, which is event tick or begin play or event actor overlap. So we can modify that behavior by converting on the outside of this macro this event name into a variable. which we can do by dragging it over to the left and telling it to promote to variable. And then in each one of these events, we're going to create or drag the event name variable into our graph, and then choose set name, connect it up, and then provide a different name here. So tick. And this will actually set the variable name equal to tick whenever the trigger comes from event tick. Then it'll subsequently call this play sound and give money. So I'm going to go ahead and duplicate this a couple times and tell it that whenever we come from the event begin play, we will instead set that variable name to begin play. Make sure to connect up. There we go. And then finally, actor begin overlap. So compile, save, play. There we go. Walk over here to make sure our actor begin overlap is still, there we go. So you may have noticed when we've been going into the play-in editor that the tick event is going to fire first 2 times, and then the begin play event will fire, followed by event tick every other 2 seconds as well. So that happens because event tick will not start firing until event begin play fires. So the very first time that event begin play fires off, event tick will be fired off in the same frame, and then it will continue every 2 seconds because we changed the mod actor's tick interval to fire every 2 seconds. Because the event begin play fires, and then immediately we tell it to wait for 5 seconds, during the 5 seconds that this delay is going on, the event tick is still firing. So let's say we wanted to change how that functions, and that we want the event begin play to wait for 5 seconds, and we don't want any tick events to fire until this node is entirely finished. So we can accomplish that by adding in some conditional logic. We are going to add in, immediately after an event tick is fired, we're going to add in something called a branch. And what a branch is, you can think of it as a fork in the road. And there's a true path and a false path, or a left and right path, if you want to think of it that way. And this execution will only go down one of these paths. So it'll either go down the true path or go down the false path. Which route it takes is dependent upon this true or false condition that we provide to it. We want to create a variable that will be false while this delay is running, or at least until event begin play reaches this point, and then it will be set to true, and then be true from that point going forward. So we can create our own custom variable, which is a Boolean variable. Boolean just means true or false. It's a variable that contains a value that is either on, off, true, false, 1, 0, however you want to look at it. Instead of, I could just promote to variable here, but let me show you how to make a variable using this panel on the left. You just go under these variables, click this plus sign, and by default it's going to be a Boolean, but we can change that by clicking on this data type value. We can pick, I'll go over what a lot of these are in future tutorials, but for now let's just worry about creating this Boolean variable. I'm going to rename this to begin play done. And I will set the default for this. If you look on the right, once we create this variable, we have some options over here. And under default variable, it's telling us, please compile the blueprint. So we're going to compile. And then once we do that, we now get the option to give this variable a default value, meaning that whenever it is created, whenever our mod actor is created, this will be given a essentially a preset that the first time we reference it, that'll be its value until we change it. Its default value right now is false because it's unchecked. So we're going to leave it that way because that is the default behavior that we want. And we're going to keep that variable as false until we reach the end of begin play. So I'm going to drag this variable up here, drop it, and say set begin play done, connect it up so that it is in the so that it is in line with our begin play. And then at the very end, we're going to set this to true, meaning that now we have completed begin play. And now we can use this variable in here. So I'm going to drag begin play in again. And this time I'm going to say get begin play done. So basically get the value of this variable whenever it's being asked to check it from this branch node right here. And what we want to do is whenever event tick fires off and it tests the value of begin play, we only want to run this set event name as tick and then the play sound and give money when this variable has a value of true. So we're going to connect this true output execution pin to set. And we're just going to leave false as nothing. So what that'll do is every time this event tick fires and begin play has a value of false, then it'll try to execute this false execution pin. Nothing's connected, so it'll just stop. But once event begin play reaches this point, it'll set the variable to begin play done to true. And then because we're not changing it anywhere else, it'll be true for the rest of the time, or for the rest of the game session while we're playing. And thus, event tick will end up being true, or excuse me, the begin play will end up being true. This branch will evaluate and send out the true execution path and then work. So let's see what that now looks like if we compile, save, and then play. What we are expecting is that we won't hear anything until 5 seconds has elapsed. Then the play sound from begin play will fire off, and then we'll hear the event ticks start to propagate and fire off. So let's see if that is what is actually happening. Yep. There we go. There is something as your blueprint graphs start to get bigger and bigger, it can become a little bit harder to understand what certain parts of your graph are actually related to. So it can be very helpful to put comments inside of your graphs to section off portions of your logic so that whenever you come back and look at it, let's say you haven't looked at this particular blueprint for a while and then you need to go back in and change something, you can leave yourself little notes. So I'm going to do that real quick with this first collection of these 3 nodes up here. So I'm going to highlight all 3 of them, and then I'm going to press C on my keyboard, which will give us this little comment block, and it'll wrap around all 3 of these nodes. So I'm just going to summarize what the intention of these nodes are. So now we have essentially a section of our code that has a comment associated with it to try to make it clearer to us when we look at this down the road, what the intent of putting this little portion of collection nodes in to our graph, what we wanted to accomplish in doing so. And when you surround a certain section of your graph with this comment block, it also means you can move without having to implicitly highlight all these. You can just hold the header of your comment block down, move things around, and it'll move everything that it contains as well. So it's nifty to move things out of the way temporarily and then move them back if you need to reorganize the location of logical pieces of your blueprint. So I'm going to go ahead and do that again with this guy down here. I'm going to make a comment and say, seems like a decent comment. So the last thing I want to cover before we actually start testing this in the game is let's look at the execute console command here, and let's separate out this the command itself from the amount of money that we want to add. Let's turn this into a variable so that we can actually edit it outside of this macro and potentially outside of this blueprint. Because right now, if we wanted to change the value of the command that we're running, we have to retype it again or figure out where the numbers are in here. It's just a little bit messy. If they were static and we never wanted to change it, then we just leave it like it is. But let's go ahead and separate out the command from the number. I'm just going to cut the text out, drag out from command, and I'm going to make a new node called append. And what append does is you can provide it with multiple inputs of strings, and then it will combine these separate strings into a single string to which it'll output on its return variable or return value output pin. Now, what I want is I want the first string to be the name of the command we want to run. I want the second string to just be a space, because there needs to be a space between the command and the number we're going to provide for the amount of money that we want to add. And then finally, I want string C, which isn't here yet, to be the string representation of however many coupons we want to add. So first thing I'm going to click on add pin to give me one more string into the collection of strings that we're going to smush together. And then I'm going to drag off of pin A and then type in make literal string. And that's where I can paste this in. I'm going to cut out the number, and that's the first part of our literal string. So the command to be the first part. Next, I want to go to B, and I just want to press space once so that all B contains is just the space character. And then finally C, this is where I want to put the amount of money that we want to add to the player. So here I'm actually going to create a new variable, and we're going to call it money amount. And it's not going to be a Boolean because we don't want it to be a true-false value. We need it to hold a number, and the type of number we want it to hold is a whole number. So integer. Integer means whole number. And I can compile and provide a default amount of, I think we were using, what, 100,000? So that's the default amount. And now I can drag in money amount, get money, and then I can connect these two pins up. Now, you'll notice there's a different color here. So this is aqua greenish type color for integer, and we have a magenta color over here for string. So an integer is a completely different data type than a string. One holds numbers, one holds essentially characters, alphanumeric characters, and symbols and spaces, and not just numbers, so to speak. So if we drag from here on money output to C, we can see that before we drop it, it says it's going to convert the integer to a string. So that's very nice of it to do for us. So it's going to take that number, it's going to take whatever that number is, it's going to convert it to a string representation of that number. And then that string representation is going to be provided as the third string that we're going to append all together. Whenever you're doing appends, I do also recommend to connect up another PrintString method so you can see what the output is. It helps you for debugging. I am also going to drag out from return value, which is now connected to execute console command. I'm going to drag this out, and I'm going to say print string. And I have to connect this print string up to an execution like all these others here. I'm just going to go ahead and throw it up here and connect these all in line. And then finally, I'm going to compile, save, and then we'll run this again. There we go. So now we can see not only is the tick and begin play and every other event going in, it's also giving us an output, letting us know what our appended string looks like. So the next thing that we're going to do is we're going to look at, okay, how do we modify these variables and expose them as configuration options to anyone who may use this mod. So there is a convenient property that you can set on any variable that you want to allow people to edit through a configuration file. So if we click on any of these variables and we look over in details, there is an option. If you expand advanced over here, there's an option called config variable. And again, our tooltip kind of gives us a little bit of a clue of what this is. It gives us some helpful information. And basically, enabling this checkbox will allow this variable to be read once whenever the game starts from a configuration file, so that we can provide a different default value to start off with other than the one we have provided it within our blueprint. So if we check this box off, look at the tooltip. At the very bottom of the tooltip, you'll notice it says that config file is engine. That is referring to the engine.ini file. And the config section is open square brace, the path to our mod actor, and then .mod actor _c, which means an instanced version of our mod actor, and then a closed square brace. So I will show you how to set up a config file to modify this value. So let's go ahead and set up that file now and test it out. Engine.ini. To get to that, from File Explorer, we would go to our user directory. So that is under C, users, username, app data. If app data is hidden, you can go under View and show hidden items. Just make sure this is checked, because app data is normally hidden by default. So app data local, I believe it's STALKER 2. Yep, there we go. And then under saved and config, and then Windows. For some users, this may be WinGDK, but we would click on either Windows or WinGDK. And then in here, we will have an engine.ini file. Some people may not have that. And if not, you can just create it. Just right-click, say New Text Document, and then type in engine, get rid of the extension, and call it .ini. Now, I already have one, so I don't want to override my existing one. So I'm just going to say escape and delete. So I'm going to open up my existing engine.ini in a text editor. So I'm just going to choose Notepad. And I'm going to bring this over here to the left, put Unreal Engine over here on the right. And I'm going to go to the very bottom of this file, and I'm going to add in, if I hover over that config variable, and I'm just going to go ahead and do a little quick print screen. Because if I move it from, if I move my cursor away from config variable to go type this in, it's going to go away. So with that print screen up, I'm going to put a new line in here that is verbatim the square braces and then whatever is in between. Open square brace / game, and then close brace. And then after that, I can put in whatever value I want to be the default value for money amount other than its default, which is 100,000. So for money amount, we have to provide it whatever the actual name of the variable is over here. You'll notice that when you look at default, and Unreal Engine does this quite a bit, but the name of money amount is actually, there's no space in it. There's capital M-O-N-E-Y and then A-M-M-O-U-N-T. I'm not even sure if that's spelled right, but whatever, that's how I'm spelling it. There is no space in the name. This is just Unreal Engine trying to make things look friendlier. But we have to use this with no space whenever we're defining our configuration file. So I'm going to type in money amount equals, and then whatever value I want to have as the default as opposed to its normal default of 100,000. So let's just say 100. Just to have something different. So I'm going to go ahead and save this, maximize Unreal Engine again, and I'm going to make sure that everything is saved. And I'm going to package this, and we're going to test it inside of the game. So for packaging, just make sure everything is saved. And we're going to go to Windows, Package Project. So whenever that's done, we can go to our projects folder under STALKER 2 Windows, STALKER 2 Content and Packs. And remember, we had this as pack chunk 4444. So I'm going to copy all 4 of those, go to my STALKER 2 Logic Mods folder, paste those in, and then press F2 to rename it to Add Money, the name of our mod. Now we can open up the game and see if everything is working as we would expect. There we go. So now we should be getting 100 every time this goes off, so let's see if that's the case. Yep, so we're up to 700 now. Now we're up to 1,100. 1,400, etc. So that'll be it for this video. Going forward, what I imagine we'll cover next will most likely be widgets and how to actually put user interface and notifications on to the screen, so that instead of having to use a config file to change the amount of money we're giving, we'll create a little user interface widget where we can modify it within the game. So if we want to change the value of the money going forward, we could use an in-game setting as opposed to a file that is read only when the game is launched. So that'll do it for this one. Hope you enjoyed it, and I hope to see you in the next one.